the very last piece of our recap here, so congratulations everybody for surviving, is the vector. You'll remember that a vector acts very, very similarly to an array, only with a little bit more flexibility, right? So in an array, what happens is there are a set number of elements in that array. C++ does not do any boundary checking. It does not know, well, it does know, but it does not care if you go over the number of elements into that array. So if we're trying to read 7 elements from a 5-element array, that's 2 elements too many. That's not a huge deal, but if we're trying to read 7 elements into a 5-element array, that is a huge deal, because elements numbers 5 and 6, because remember, in an array, just like here in a vector, the element number is n minus 1. It's number minus 1 because they start with 0. So with an array, we can run into an issue when we are moving past the boundaries of the size of the array. Now, a vector is more forgiving after a certain effect, because if you run into a situation where you are about to run over the bounds of your vector, you have declared that, like this example that you can see below, or it's actually above me here, that if we have declared that there are 5 elements in our vector, and you start reading in element number 6, number 7, number 8, number 9, what C++ actually does is find another storage location that is more appropriate. It will make a copy of that vector. It will resize that vector, and it will change all previous references to its pointer. So the map location in storage, in memory, in a server farm someplace, if we're using Replit here, and it will remap all previous pointers to the new one. That comes with heavy lifting on behalf of C++. So that operation is nowhere near as fast, and it is nowhere near as efficient as it is if we were to use an array. But the lazy developer in me says, yeah, but there are circumstances where I'm going to want to be able to resize an array, and the vector gives us the opportunity to do that. So before we get into any of that, let's run through here my example. And I guess I didn't realize, but the output is already here. In this example, I am using a simple for loop to do for me the lion's share of the work. I'm going to use a for loop, an enhanced for loop rather. I'm going to use an enhanced for loop to get values into my vector, and I'm going to use an enhanced for loop to get values out of my vector. So here on lines 13 through 17, we are reading values in. One wrinkle here to be aware of. You'll notice I have the ampersand there, and you'll remember from, chapter 6 at this point, and earlier, is that when it is that I want to reference, or I want to pass by reference, so I don't want to say reference a reference, right? What I'm doing is I'm actually providing a pointer location. I am providing an actual physical address someplace in storage, or someplace in virtual storage here, where that variable is actually going to reside, where the values that are packed into that variable are going to reside. This only works if I use the ampersand there, because of the way that a vector works. So you can see the output over here. I have simply added 1, 2, 3, 4, and 5 as the values of the 5 elements in my vector. And then here, in this second enhanced for loop, I can simply vomit out the values in my vector. But let's break this just really briefly here. All I'm doing is on line 13, I'm taking away the ampersand. And if I run this time, enter a value, 1, 2, 3, 4, 5. Here are the values that you entered. Nothing, 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 nothing. What is the reason for that? The reason for that is we are not using the same location that we're using for our vector numbers. The ampersand here is what is letting C++ know that we are entering in the values here that you can see with the enhanced for loop based on its actual location in storage, and we need that inclusion here. So all I did was put the ampersand back, 10, 20, 30, 40, 50 to give me slightly different responses here, and then I'm using that enhanced for loop on the way back out. If we were to change this piece of code, if we were to, instead of the enhanced for here, or in addition to this enhanced for, if we were to add more integer elements to the back end of that vector, we can do that actually. Remember that piece of magic we described earlier on. C++ is going to realize, they're adding or trying to add more elements to the array than they have allotted for. So it goes through, it finds a new storage location that is larger, it copies each one of the values of those elements over, and based on that pointer, we now have more elements in our vector. And all of that did come at a penalty, but it was all felt on the back end instead of by you as a developer. And the very last thing we're going to look at here for vectors in our next video is push and pop.